Yeah, good morning, students. Good morning. Very good morning. Okay, so shall we start with the class? Hmm? Yeah, Stefan. Before I am asking question, you are writing. Yes, very good. So Heisenberg's uncertainty principle. Yes. So we had started with structure of atom. Okay. Now, in that we have discussed with de Broglie's equation. De Broglie's equation, right? Then, as Stephen has written, yes, we have even discussed about Heisenberg's principle. We have discussed about Heisenberg's principle. ಹಾಗಾದರೆ what is that de Broglie's equation? De Broglie's equation is nothing but lambda is equal to h by mv, right? So lambda is equal to h by mv. Very good. So Stefan, yes, we have even discussed about Heisenberg's principle. Now, what is de Broglie's equation? That is wavelength is equal to Planck's constant divided by mass of that particular element or matter into velocity of that particular element. That is because why we are talking about velocity, because de Broglie's equation tells that any matter, anything which is under motion in the nature, anything which is under the motion in the nature can show dual property. So which is that dual property? So that dual property is, one is particulate property, that means they will have energy and all, and another one is wave property, and another one is wave property. So yes, dual nature of a particle under motion. Okay, so it should be particle. Okay, done. So that's where we have the dual properties or dual nature, which will be shown by the particles under motion. Okay, so that's where de Broglie's equation can disprove, or by using de Broglie's equation we can disprove the Bohr's atomic model, because he didn't consider the wave nature of the electron, right? So that's where we have one of the limitation of Bohr's atomic model. All of you have understood? Fine. Now we have solved some of the problem related to de Broglie's equation. Now along with that we have discussed about Heisenberg's principle. Still we have to solve the problem today. Okay. Now what is that Heisenberg principle talks about? It talks about uncertainty with respect to position of a particular matter and uncertainty with respect to momentum of a particular matter, which will be greater than or equal to h by 4 pi, which will be greater than or equal to h by 4 pi. So that's where we have the Heisenberg's uncertainty principle. Now, since this is momentum, we can write it as delta x m into v greater than or equal to h by 4 pi. Uncertainty with respect to position, uncertainty with respect to velocity, not with respect to mass, with respect to velocity. Here also mv can be written as h by p, no doubt. That means momentum. Okay, so that's where we have the Heisenberg's principle, and that's where we have the de Broglie's equation. So if I want to define, if I want to state the Heisenberg's principle, so what I have to tell? I can tell that for a dimensionless particle like electron, for a dimensionless particle like electron, it is impossible. It is impossible to find the velocity and the position simultaneously. Two important words, impossible and simultaneous. Okay, and other two important word is position and velocity. So that's where it is uncertain with respect to position and it is uncertain with respect to velocity or momentum. Okay, so all of you have understood. So that's what Heisenberg principle talks about. So once again, by using Heisenberg principle, we can disprove the Bohr's atomic model. Why? Because according to Bohr's atomic model, electrons will be revolving around the nucleus in a definite path. Definite means I am very sure that its position also, its velocity also. Then only I can definitely tell that this is the path taken by the electron. But it is impossible, according to Heisenberg's principle, it is impossible for an electron to have or to find the position and velocity of the electron simultaneously. When we cannot find position and velocity simultaneously, how we can tell that this is the position or path taken by the electron? It's not possible. Okay? So all of you have understood? So therefore, de Broglie's equation, by using de Broglie's equation, yes Pooja, yes, you are absolutely right. So therefore, based on the de Broglie's equation and Heisenberg's principle, we can disprove the Bohr's atomic model, or that can be included in limitations of Bohr's atomic model. Fine? Shall we move to solving the problem related to Heisenberg's uncertainty principle? Okay. So any doubts? Whatever we had done in the last class, any doubts with respect to that? Okay. So in that case, we will solve two problems maximum, because we have to finish the topic also. Not today. We are going to finish the topic in another 2 days. Okay. So now, a microscope, all of you can write down, this is the problem related to Heisenberg's principle. Okay, a microscope used to detect a electron in an atom. Electron in an atom within a distance of 0.1 angstrom. Okay, so a microscope used to detect an electron in an atom within a distance of 0.1 angstrom. Find the uncertainty. Find the uncertainty involved in the measurement of velocity of the same electron. So once again I will repeat, I am changing the marker so all of you can see. So a microscope used to detect an electron in an atom within a distance of 0.1 angstrom. Okay, so that is related to position. Now find the uncertainty involved in the measurement of velocity of the same electron. Fine. So we have to apply equation, Heisenberg's equation. Can you try it out? You can start. Whoever have understood the problem, we can start. Is an electron microscope? Yes, in the regular microscope it's not at all possible. Okay. Simply for the problem purpose they have given microscope. Okay. Regular microscope it is impossible. Okay. So we will start. So what is that equation? Please remember, for writing the proper equation, you will get the mass delta x into delta p is equal to or greater than or equals to whatever it is. We will mark it as is equal to h by 4 pi. If you recollect, we had written as general equation as delta x delta p greater than or equals to h by 4 pi. When we were telling greater than or equals, so or equals is that, so therefore equals to h by 4 pi. Since they have asked about velocity, we will rewrite the equation, or we can write the same equation as m into delta v is equal to h by 4 pi is equal to h by 4 pi. So from where we got m delta v, that is from the momentum. P is equal to mv. Mass we know, velocity we have to find out, uncertainty with respect to velocity. Now what we have to find out? Uncertainty with respect to velocity. So we can rewrite the equation. So therefore delta v is equal to h by 4 pi, then m will also come this side, m into delta x, m into delta x. All of you have understood? So we have to calculate uncertainty in the velocity of the same. So we will keep it on the one side and rest of the things we will push it on the other side. So by using this equation only we have to solve. From where we have got that equation? From here, from Heisenberg's uncertainty equation or Heisenberg's equation. Fine. So we have to apply that particular equation. Now h value we know. So before going for that, what is mass? Whether they have given the mass, so whether they have given the mass, don't worry, they will give at least in the bracket. But at this moment, in the question, whether we can see any mass value? No. But since they are talking about electron, since they are talking about the electron, we have to consider mass of the electron. Okay, don't worry, they will give the value. So we have to consider the mass of the electron. Mass of the electron is 9.11 into 10 to the power of minus 31 kg. 10 to the power of minus 31 kg. So that is the mass of the electron. All of you have understood? Now what is that next? They have given the uncertainty with respect to position, but that is in terms of angstrom unit. That is in terms of angstrom unit. Yes, Chitwan. So that's what I have written. Okay, in the beginning of the class only, we have found the mass of the electron. Right? So now, anyway, this value they will give, don't worry. Now, with respect to the position, what they have given? 0.1 angstrom. So 0.1 angstrom, we have to convert that one into meter. We have to convert that one into meter. So therefore, delta x is 0.1 angstrom, which is nothing but how to convert that one into meter? Anyone? How to convert angstrom unit into meter? Angstrom is smaller form of the meter only, don't worry. But we don't want in angstrom form, which is a very, very small value. We want in terms of meter because other things will be in meter. That's why. Yes, very good, Chidwan. Yes, you are absolutely right. So 0.1 into 10 to the power of minus 10 meter. Right? So from where we have got? We have got this one by using 1 angstrom is equal to 10 to the power of minus 10 meter. From this information, this one they will not give, they may not give, but you should be knowing, Likita, it is minus 10, 10 to the power of minus 10, not 10 to the power of 10, it should be minus 10, okay? So that's where we have the 10 to the power of minus 10 meter. Fine, all of you have understood? And H, we know the value, Planck's constant, don't worry, they will give. Yes, Shubhangi, absolutely correct. 0.1 into 10 to the power of minus 10 meter. Now we will substitute those values over here. Delta V is equal to. So Planck's constant is 6.626 into 10 to the power of minus 34. 10 to the power of minus 34 joule second. 10 to the power of minus 34 joule second. From where we got this value? This is nothing but Planck's constant. Okay, that is H value. So 4 into, what is the pi value? That is 22/7, or you can simply write it as 3.14. What is pi? Pi is nothing but 22/7, or we can simply write it as 3.14 multiplied by, what is that? Next, mass of the electron. So that is 9.11 into 10 to the power of minus 31, it is in kg. Okay, multiplied by delta x. What is delta x? 0.1 into 10 to the power of minus 10 meter. 0.1 into 10 to the power of minus 10 meter. So these are the values we have substituted. So these are the values we have substituted. All of you have understood until now? Shall I remove these things? All of you have understood? Shall I remove this one? Okay? Yeah. Ria. Okay, very good. So delta V, we will see whether that will be the answer. Yeah, absolutely correct. Your answer is absolutely correct. Okay. So I will remove this. Okay. But I think Ria, first time I am seeing, or earlier also we were having interaction. But very good. I am very happy. Absolutely correct answer. Okay. Now, delta V, as I told, since we are talking about velocity, the unit should be meter per second. Unit should be meter per second. That is one thing. So to have the meter per second, we know that 1 joule is equal to. So we know that 1 joule is equal to. What is that one? That is 1 kg meter square per second square. So this is the thing. So 1 joule is equal to 1 kg meter square per second square. Why? I have told joule is nothing but it's a force, and the unit of force is Newton. So therefore please remember, Newton is equal to joule meter. It will be joule meter. So therefore it will become meter square. Okay. So that's where kg meter square per second square. So that one I will substitute here. 6.626 10 to the power of minus 34. If you remember this one, fine. Otherwise, final unit you should write properly. Minus 34. I will write it as kg meter square per second square. second, because 1 second is already present. Okay, so divided by, now multiply 4 into 3.14 into 9.11 into 0.1. What you are going to get? Multiply those denominator values. So that will be somewhere around 11.442, right? 11.442, and how we got 11.442? This one, this one, this one, and this one by multiplying that into 10 to the power of minus 31 and minus 10. It will become minus 41. So 10 to the power of minus 41. Okay, so which are those units? Meter and kg. We have the meter and kg. Okay, we have the meter and kg. Okay, fine. So therefore, delta V is equal to, we have to divide 6.626 divided by 11.442, and it will become 0.579 into 0.579 into, now minus 41, if I take it on the top, it will become plus 41. So plus 41 minus 34, yes Shubhangi, it should be 10 to the power of 7. It will be 10 to the power of 7. Now meter and meter will get cancelled, kg will get cancelled, and 1 second and another 1 second will get cancelled. So what is left over? Meter per second. What is left over? Meter per second. Okay, so that's where we have the uncertainty with respect to velocity. What is that answer? 0.579 into 10 to the power of 7 meter per second. Sir, we don't want in decimals, sir. Please, we will make it as 5.79. No issue. So 5.79 into 10 to the power of 6 it will become. Okay, so that's where we are going to get the answer. All of you have understood? So what you have to make a point here is, you should know what is that mass. Since we are dealing with electron, we have to take the mass of the electron. That is one thing. Okay. So next thing is 0.1 angstrom has to be converted into meter. So those are the two things which we have to make conversion. Fine? Okay. So in that case, we will move to another problem, then we will move to next problem. Okay, we will solve another one, but you have to practice with some more problems present in your textbook and check sheet. Make use of those two, textbook and check sheet. Once you are thorough with your NCERT book A to Z, then only go and read the competitive exams books. That's what my suggestion. Okay, don't try to construct a building without proper foundation. Okay, so first completely read each and every word. You should be thorough, whatever topic has been done. Then only go for some more problems, some more concept which is present in your competitive exam books. This year onwards only you should start. Don't go postpone it for second year. Okay, so we will go with another one. A ball of mass, 30 gram, and speed of 50 meter per second. This way you can write, or you can write it as 50 meter per second. One and all same, no difference. Okay, so 50 meter per second. If the measurement of speed, of speed is with accuracy of accuracy of 2%, calculate the uncertainty, calculate the uncertainty in the position. So in earlier case it was with respect to velocity. Now they are talking about position. Any one of you or you people can try it out? Okay, done. So what is that question? A ball of mass 30 gram and speed of 50 meter per second. Okay, so now if the measurement of speed is with accuracy of 2%, calculate the uncertainty in the position. Now if you are not understanding the question, you have to read 2-3 times. Now observe here carefully. They have given the mass, but that is in terms of gram. You have to convert that one into kg. Then they have given the speed. That is 50 meter per second. But with respect to uncertainty, they have mentioned it as 2%. It's not accurate. There is some uncertainty of 2%. Now we have to calculate. For 100 if it is 2, how much for 50 meter per second, how much uncertainty? Okay, then you are going to get the delta P value. Now calculate the uncertainty in the position. You have to calculate the position. Yes, Yagnesh, you are absolutely right. That's where you should read the question. Fine, you can try it out. I am giving some time so that whoever is trying it out, you can start. Okay, that's fine. 1 meter per second. Yes, absolutely correct. Now I want final answer. It should be 1 meter per second. Yes. We have to find out uncertainty with respect to position. Yes, it is 1 meter per second. That is for uncertainty with respect to speed. Final answer is different. 10 to 1.46. Okay, 10 to the power of minus 33. Yes, I think it should be correct answer. We will see. Yes, Yagnesh, we will see. Okay, now uncertainty with respect to WRT means with respect to speed is 2%. Okay, so 2%. So therefore for a given speed uncertainty is what is that? For 2% means for 100 it is 2, uncertainty is 2. How much for 50 meter per second? Okay, now naturally 50 into 2 is 100, 100 divided by 100 is 1, so 1 meter per second. Many of you had written. Yes, that is uncertainty with respect to speed. Okay, now second point. Now we have to apply the equation delta x into delta p. We will take it as equals to h by 4 pi. H by 4 pi equals to h by 4 pi. Okay. Now they have asked about position and we know speed. So therefore we will rewrite the equation as delta x into m into delta v is equal to h by 4 pi. right? M into delta V is equal to H by 4 pi. Okay. Now we will rewrite the equation so that uncertainty with respect to position should be on one side of the equal sign. So delta x is equal to H divided by 4 pi into my mass into velocity, delta V. Uncertainty with respect to velocity. Okay. So we have to substitute the values here in this equation. Okay. So we have to substitute the values in this equation. So therefore delta x is equal to 6.626 into 10 to the power of minus 34 joule second. So from where we got, that is nothing but Planck's constant. Now 4 into, what is pi value? All of us we know it is 3.14. Just now, earlier problem we have seen 3.14. Now they have given 30 gram, 30 gram mass. It has to be converted into kg, because joule and all we are going to convert it into kg. So we will convert that one into kg. So that is, it should be 30 or 50. 30, right? Yeah. So 30 into 10 to the power of minus 3 kg. So 10 to the power of minus 3 kg multiplied by, what is delta V? Delta V is nothing but 1 meter per second. 1 meter per second. Okay. Okay, here I did a mistake. I have taken in the problem 30, but while solving I have written 50. So my answer will not be correct. So you have to guide me now. Okay. Now delta x is equal to 6.626 into 10 to the power of minus 34 joule. I will write in terms of kg meter square per second square. Kg meter square per second square into second. Okay. So now can you tell me 4 into 3.14 into 50? How much? 4 into 3.14 into 30. How much? Here the problem is I have taken 50. I don't know why I have taken 50. So 4 into 3.14 into 30. How much? So 376. Okay. So it will be 376. Okay. So 376 into 10 to the power of minus 3 kg meter per second. Kg meter per second. Okay. So 376.8. Okay, fine. 376, or we can make it as 377. Since 0.8 is there, anything is fine. Okay, in that case I will write 0.8 as, or you can take it as 377, round off. Okay, so 1 second has gone. Now another 1 second, another 1 second has gone. No seconds. Okay, now meter, 1 meter it is gone. Kg it is gone. So the end result will be in terms of meter. Distance, position, it is with respect to meter. Okay. Now can any one of you tell me 6.626 divided by 376.8? What will be the answer? 6.626 divided by 376.8. What is the answer? Ignish, we will see. So 6.626 divided by 376.8. What is that answer? Oh, 0.0175. Sneha, 1.75 it may not be possible. So it should be 0.0175. Okay. So delta x is equal to 0.0175 Now if I take this one on the top, it will become 10 to the power of plus 3. So minus 34 into plus 3, that is nothing but minus 31 meter. So that should be your final answer. Okay, that should be your final answer. Okay. So if I want to have 175, then you can make it as 175 point. How much? Decimal point has to be shifted. So that means same thing, changes has to be done for 10 to the power of minus 31 also. Okay. So all of you have understood? Fine. So that will be your final answer. This is with respect to calculation related to Heisenberg's principle. Any doubts in this? So what we have done here, first we have to calculate what is that uncertainty with respect to velocity or speed, because they have given 2%, they have not given uncertainty, they have given the 2%, we have to calculate. So that one we did, right? So then what else? Then we have calculated, we have substituted those values, then we have calculated the answer. That is uncertainty with respect to position. What is that unit? Meter. Okay, since we are talking about the distance, not per second, only length or position. So therefore, meter. Okay. Any doubts? So hagadre we have done with this one, answer Heisenberg's principle. So what will be the advantage of Heisenberg's principle? That's what it's going to disprove the Bohr's atomic model. Okay, all of you have understood. So shall we move to the next one? So this is also very important. Okay, so please note, sometimes I am telling important, sometimes I am telling very important. Okay, so Rakesh, no sir means have you understood, or it's answer for whether you have any doubt? That's for that answer, I think. I don't know. You can ask if you have any doubt. Any one of you. Okay. So otherwise I will move to next one. So if you don't have any doubt, shall I move to the next one? Okay. Now, what and all atomic model we have seen? One is Thomson's atomic model, then Rutherford's atomic model, then we came to Bohr's atomic model. So all these atomic model, they are having their own advantage and disadvantage. Okay, they are having their own advantage and disadvantage. So therefore, since they are having limitations, yes, then in that case I am moving to next one. Since they are all these atomic models, they are having the limitations. So that's where a new model or new concept came into existence, which you are going to study even in your physics also. Okay, so that's where we have, yes, all those J.J. Thomson's model, Rohan, or with respect to Bohr's atomic model, Rutherford's atomic model, all of them, they are having limitations. They are not 100% correct. Okay, so therefore a new thing, new concept is there, that is quantum mechanic model, that is related to quantum mechanic model. Okay, so which was actually developed by Heisenberg and Schrödinger. It was actually developed by Heisenberg and Schrödinger. They did work independently in different labs. Schrödinger, they did their work independently. They are not together. Okay, so these two people are the one who contributed towards the development of quantum mechanic model for the structure of atom. All of you have understood? Now, I will make it very clear. All these days, until Bohr's atomic model, we used to talk about orbits. Now, no more orbit word should be used. In quantum mechanics model, orbit word will not be used. No orbit. Okay? So it will be orbital. In quantum mechanics model, we are going to use the word orbital. No question of orbit. Orbit only up to Bohr's atomic model. So I will make it very clear. In a hurry, students in the examination they will write. So Bohr's atomic model, while writing the Bohr's atomic model, they will tell that electrons will be revolving around the nucleus in a definite path called as orbital. Marks gone. It's not orbital, it is orbit when it comes to Bohr's atomic model. But when it comes to quantum mechanics model, orbit word should not be used, it should be orbital. Hagadre, what is that difference between orbit and orbital? That's what in the beginning we are going to understand. I am going to have the explanation for that. Okay? Now, we have one particular word called as wave function. We have one particular word called as wave function. So symbol is psi. That word is psi, where P will be silent. So psi. Some students they will tell psi, psi. Not like that. P is silent, psi. So wave function. Okay? So that's where we have the psi. What do you mean by this wave function? Wave function, in the name itself it is there. It is related to waves. Waves of the electron. It is related to waves of the electron. Okay? Which talks about position and energy in terms of amplitude. Okay? So that's where wave function. What do you mean by wave function? It is related to waves of the electron which deals with the position and energy of the electron. So that's where we have the wave function. Okay? So symbol is psi. This is not there in case of the Bohr's atomic model. This is applicable with respect to quantum mechanics model. All of you have understood? Fine? Yes, Rohan. Yes. Okay, that's where we have the wave property of the electron which has been done here. Even they are talking about energy also. That means particulate nature also they are dealing with. So that's where it is advanced compared to Bohr's atomic model. Okay. So any doubts in this? That's where we have the Bohr's atomic model. So we have a Schrodinger equation. So we have a Schrodinger equation. Don't worry, they will not ask how this equation came and all. Okay? So when you go for higher studies, then only you can understand. That is Schrodinger equation. That is nothing but H psi is equal to E into H psi. H is a Hamiltonian symbol or Hamiltonian terminology. Okay? So that's where we have the H psi is equal to E psi. E psi talks about total energy and wave. It is nothing but total energy and wave. So that's where we have the Schrodinger equation. This is nothing but Schrodinger equation. I will explain it once again. So when it comes to quantum mechanics model, one thing we should know is wave function. Symbol is psi, because for 1 mark they will tell what is psi. Then you can simply write it as it is a wave function. You are going to get the 1 mark. That's where we have the wave function psi. Now what it deals with? Wave function deals with the energy and position of the electron around the nucleus in an atom. So what is that? It deals with the waves of the electron, which talks exactly about the position and energy of the electron around the nucleus in an atom. Okay, that's where we have the wave function. So what is psi? If they ask, you can just tell that it is the wave function of the electron. That's all. Okay? So what is Schrodinger equation? Schrodinger equation is H psi is equal to E psi. So H stands for Hamiltonian terminology. It is nothing but mathematical terminology. Hamiltonian. Okay? So H is nothing but Hamiltonian mathematical expression. Okay? So H psi is equal to E psi. But E psi, if I want to talk about it, it deals with the total energy. Waves with total energy. From where this total energy came? So that total energy can be due to electron-electron repulsion or velocity of the electron. So that's what? Kinetic energy, potential energy, all this energy together we are having total energy. Okay? So that's where we have the Schrodinger equation. More explanation about Schrodinger equation is not there for you people and no need to worry also. Okay? So that's where we have the Schrodinger equation. Okay? So now we have another thing. For 1 mark they can ask, 1 mark this one you can expect, or we have another symbol, psi square. What is psi square? They will ask. What is psi square? Then you should tell that psi square is the probable area or region. It is the probable region around the nucleus where density of electron is more. What is psi square? It is nothing but probable. It talks about the probable region around the nucleus. Around the nucleus where density of electron. Okay, I will make it very clear. Density of finding the electron. Otherwise, density means mass by volume, right? So we are not talking about that density. Density with respect to finding the electron. Density with respect to finding the electron. Finding the electron is high. Okay? So that's where we have the psi square. So what is that psi square? Psi square talks about area, region. However, what is that? That region is the one where probable of finding the electron around the nucleus, it will be more or very high. So that is the significance of psi square. It is related to once again wave function only. Okay? But only thing here is wave function just deals with an electron. Okay? So where it talks about its position and energy, but psi square talks about the region around the nucleus. So what is that? Wave function deals with the position and energy of the electron. But when I am talking about psi square, it deals with the region or area around the nucleus where probability of finding the electron is more. Probability of finding the electron is very high. So that's where we have the psi square. Any doubts in this regard? Any doubts? So what we have to understand here? Wave function, psi square. They have asked for 1 mark. Okay? So these two along with that Schrodinger equation. Any doubts in this? So that's where quantum mechanics model is going to deal with the wave and energy of the electron. Wave nature and energy of the electron. Both they are going to deal with. Okay? So in that case, shall I move to the next one? Okay. So if we have a discussion on the next one, that is in quantum mechanics model only. Now I can tell whatever I will be telling, I will include another V. Very, very, very important. 3 to 4 marks question, or it can be even for 1 mark. They can expect the question from these concepts. That is quantum numbers. That is quantum numbers. ಹಾಗಾದರೆ when I am talking about quantum numbers, it is the exact pin code address, it is the postal address for an electron. What, sir? Postal address for electron means what? Say for example, where Learners PU College in Mysore it is located. If someone asks you where you are studying your PUC, if you tell Learners PU in Mysore, then people will laugh. Okay, fine, you are studying in Mysore your PUC, but exactly which college? Now you will tell Learners PU College. Then they will tell where this Learners PU College in Mysore it is located. Then you will tell in Vijayanagar. Then they will ask in Vijayanagar which area, exact location. Then you should tell that Vijayanagar, first stage near water tank. Then only you can talk about exact location of Learners PU College. Right? So if I want to find out where Rakesh or Shubhangi, we will imagine college has opened. Okay, Shubhangi she is in the classroom. Now we want to locate exactly where Shubhangi at present. Now for that location what we have to do? We have to tell that she is present on this earth. In this earth she is present in India. In India she is present in Karnataka. In Karnataka she is present in Mysore. In Mysore she is located at present in Learners PU College, which is in Vijayanagar first stage. That's where exact location of this Shubhangi will come, because in this world there will be millions of Shubhangi, we don't know. Okay, so that's where we have the quantum numbers. Someone had written already, which give the exact location. Yes, Stefan. If you know all the 4 quantum number of an electron, yes, it is water tank. Yes, near water tank. So, Stefan, what you have written is absolutely correct. Yes, if you know the 4 quantum numbers for an electron, that means you can exactly locate where that particular electron is present in that atom. Got my point? That's where we have the quantum numbers. Okay? So, however, what is the advantage of quantum numbers? It gives the exact location or position, exact location of a electron in an atom. It gives the exact location or position of an electron in an atom. So that's where we have the quantum numbers. Okay, fine. So ಹಾಗಾದರೆ as I told, there are 4 quantum numbers. First one, principal quantum number. First one is principal quantum number. Okay, now when I am talking about principal quantum number, okay, if I tell this principal, you will go to college then. Principal quantum number. Okay, now that is one thing. Next one, azimuthal quantum number. Azimuthal quantum number, as I told, there are total 4. Azimuthal quantum number, which is also called as subsidiary quantum number, or we can call it as subsidiary quantum number. Anything is fine. Okay, so next one, magnetic quantum number. Next one is magnetic quantum number, and the last one is spin quantum number. Next one is spin quantum number. All of you have understood? So these are the 4 quantum numbers which you are going to study. 3 and last one is 4. So principal quantum number, azimuthal quantum number, or which is also called as subsidiary quantum number. Then we have the magnetic quantum number, and the last one is spin quantum number. Fine. Now symbolical representation is important. Principal quantum number, as we have seen in Bohr's atomic model, it will be represented by small n. If you recollect, in Bohr's atomic model only we have seen principal quantum number, and I asked you people to remember this, right? So that's where we have the principal quantum number represented by small n. Then azimuthal or subsidiary quantum number will be represented by small l. Now magnetic quantum number can be represented by ml. If you observe, small m subscript l, ml, small m subscript l. Okay, so that's where it's not capital. Capital M is this one. It's not like this. Small m subscript small l. Okay, so that is magnetic quantum number. Okay, and then we have the spin quantum number, small s. It can be spin quantum number. So that's where we have the 4 quantum numbers. Okay, so principal quantum number, small n, azimuthal or subsidiary quantum number, small l, magnetic quantum number, small m with subscript l. Then we have spin quantum number, that is small s. Why I am telling subscript l? Because if you write this one, this will become milliliter, ml. It's not ml, m with subscript l. Okay, so we have to write like this with subscript l. Otherwise it looks like milliliter. Okay, so any doubt in this? Because I am going to stop here. In detail we are going to study all these things. Any doubts? In another 2 days maximum we are going to finish structure of atom. Okay, any doubts? Okay, so in that case I will stop here. So you can solve some more problems from your check sheet and textbooks. Okay, if you have any doubts, you can ask me or your teachers. Anything is fine. Okay? Okay. Thank you. Thank you everyone. Take care. Tomorrow we are going to continue. Thank you. Thank you.